Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Hakim and today I will present on our vehicle dynamic assignment. So the topic given to our team is semi-active suspension system. So this is our team members consisting of 4 people. The first one is Ahmad Fuad bin Anwar, Rohakimi bin Rusdi, Muhammad Ashraf bin Bakar, Muhammad Arif Hakim bin Shamsul Kamar, myself. So as an introduction, the purpose of this assignment was to make a literature summary of an academic paper related to our given topic. So each member of our group will have to make one literature summary based on the academic paper that we search on the internet. And the summarized academic paper will be included in the literature review page on the next slide. So number one is my academic paper. The title is a comparison of optimal semi-active suspension system regarding vehicle ride comfort. It is a journal that was published at the year 2017, and the result is ADD and PDD do not deliver good optimal result, being unable to improve both passengers' ride comfort. And optimal solutions of the rear suspension system have an almost fixed value for the spring stiffness. The SA case are unable to improve the road holding at a certain point. However, it is acceptable considering the fact that the applied control laws are comfort-oriented. Fact that the L shape appears in the front suspension system validates the necessity of using different suspension system to the front and rear axles. Okay. So the next literature review will be continued by my other teammates. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, I will continue about the project for the vehicle dynamic. Okay, so for the number 2 research paper, I choose the magnetorheological damper model influence on the semi-active suspension performance. Okay, so the name of the paper is a smart material and structure. So the paper is published on 2019. Okay, so for the methodology for this paper, the first this paper talk about the magnetological fluid damper. What is a magnetological fluid damper? A magnetological damper is an adjustable device that uses magnetological liquid as a carrier. It is widely used in machine, automobile, and civil engineering application due to its lower power consumption, quick response, easy control, and adjustable damping force. Okay, so the next for this paper is talking about a main function of damper is to dissipate the kinetic energy, reducing the motion of the sprung mass, okay, for vehicle chassis, and improving the road holding while it is possible to adjust the suspension element passively by mechanical design. It has been shown the active or semi-active system can improve performance. So the study the different effects, okay, and between two models. First model is an base model, and the second model is the different model is the Bingham model. Okay, that may appear in the closed loop performance of an automotive suspension system when the damper model is unable to represent crucial non-linear MR phenomena. Okay, and then this highlight the model influence on the controller, synthetic, and subsequently on the suspension performance. Two damper model with different accuracy level were chosen, and artificial neutral network, okay, on ANN based model is compared with the classical Bingham model. Okay, for the result of this paper, the result is that the semi-active system are less expensive, yielding a better level performance versus cost and ratio. This study only highlight the resulting model properties, but not their actual usefulness for design effective control system. Okay, assesses the resulting performance of each model the following index based on the RMS error. So the setup used in the training and testing stage by using MATLAB, okay, was used to execute the learning algorithms. On the other hand, the testing procedure was carried on the National Instrument TMC RIO 9014 real-time simulator using a sampling rate of 200 Hz. And then for the controller design, then the ANN-based model will be only marginally more effective than the Bingham model for this purpose. Okay, that's all for for my research paper methodology. Okay, thank you.
Okay, for my literature review, my academic paper title is Particle Multi-Objective Control for Automotive Semi-Active Suspension System with Nonlinear Hydraulic Adjustable Damper. Okay, for name of journal is Mechanical System and Signal Processing. The year published is on 2018. The methodology are numerical simulation, experimental, design and compare between graph neutral network algorithm (NNA) and forward neural network (FNN) algorithm, and particle swarm optimization based sliding mode control method, and lastly online hardware in loop test. Okay, for the result, we have tire deformation, suspension deflection, sprung mass acceleration, and finally the road excitation and the actual motor angle. Okay, thank you.
Assalamualaikum, my name is Muhammad Amir Ashraf. Okay, right now I will explain about literature review. Okay, the title is Adaptive Artificial Neural Network Surrogate Model of Non-Linear Hydraulic Adjustable Damper for Automotive Semi-Active Suspension System. The journal was taken from IEEE Access. Okay, the methodology that they use is they build a model to stimulate the hydraulic adjustable damper control mechanism. A modified hyperband is used to fast select a seed model by early stopping and dynamic resource allocation. Mode pursuing sampling is then performed in the neighborhood of the seed model to systematically generate more sample points while statically covering the entire neighborhood. Okay, the result that they get is an adaptive ANN surrogate model based on MHASH TRMPS can be found to have excellent performance through many experiments. However, if the early stopping strategy is ineffective for practical issues, the MHASH will degenerate into random search, which will reduce the optimization efficiency. MHASH has the potential to be parallelized since the global sampling is independent. Okay. The experimental results show that compared with the benchmark, the modeling accuracy of hydraulic adjustable damper can be improved by up to 48% and iteration resource can be reduced by up to 84%. Okay, that's all from me. We move to next presenter. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Rakib Rosdi and I will cover about discussion and conclusion. Okay, for discussion, semi-active suspension is a type of automotive suspension system that controls the damping force of the shock absorber in response to input from the continuously varying road surface. There are a few of benefits of this system. First, semi-active suspension gives the comfort sensing of driving. Semi-active suspension will adapt the varying road surface and will maintain the stability of vehicle in horizontal movement. However, semi-active suspension require complex construction, especially in mathematical modeling, and not as good as fully active suspension system. Okay, for the conclusion. As for conclusion, we discover that an active suspension provide not only vehicle ride comfort and control but also better road holding. These systems are able to tune the amount of damping in response to measure vehicle ride and handling indicator. The CES controlled electronic suspension is a semi-active suspension system that continuously adjusts damping level according to road condition and vehicle dynamic, such as speed, turning, and cornering, delivering comfort without sacrificing safety and handling. Okay, thank you.